Elastic potential energy. The total mechanical energy of an object or a system of objects is equal to the sum of the kinetic energies and the potential energies of the system. So far, we've considered that total mechanical energy could be made up of translational kinetic energy, rotational kinetic energy, and gravitational potential energy. We'll now add another form of potential energy, elastic potential energy. An object has gravitational potential energy if it has potential to do work. If an object is at a distance above Earth's surface and is allowed to fall, it can do work. Remember what work is? Applying a force to an object that causes its displacement. A spring has elastic potential energy when it's compressed or stretched because it has the potential to do work. If an object is attached to a stretched spring and the spring is allowed to relax, the spring can do work on the object. When we stretch this spring, it has the potential to do work on this object. The spring will displace the object linearly. We can consider this to be the initial position of the object. After the spring moves the object, this gives us the final position of the object. If you recall, work is equal to S times F times the cosine of theta for a constant force. S is the magnitude of the displacement of the object and is given by the change in the position of the object. F is the magnitude of the force responsible for the displacement. Theta is the angle between the displacement and force vectors. In this case, it's 0 since the two vectors act in the same direction. The force applied by the spring to the object is not constant, however, so it's not as simple as substituting in the magnitude of the spring force. The spring force is not constant because it depends on the position x. The force has a different value at different positions. The force at x initial is equal to minus k times x initial, and the force at x final is equal to minus k times x final. Remember, k is the value of the spring constant. What we can do in the work equation is replace the constant magnitude of the force with an average force magnitude. To find the average magnitude of the spring force, we add the magnitudes at the initial and final positions and divide by 2. Now we'll substitute in the expressions for the force magnitudes at the two positions. We said we could substitute in the average magnitude of the force, so the elastic work done will be given by this expression. Now we'll substitute in what we found for the average magnitude of the force. Rearranging, we get the expression in this form. Remember how we said before that the work done on an object by the gravitational force was equal to the initial gravitational potential energy of the object minus the final gravitational potential energy of the object? Similarly, we consider this term to be the initial elastic potential energy of the object, and this term to be its final elastic potential energy. This gives us this generic expression for the elastic potential energy of an object.